Today our lesson is going to be on solving multi-step equations. So we're going to start out by reviewing how to solve equations that have like terms on the same side of the equal sign. So if you'll notice in this example here, we have a 17x and an 11x on the same side of the equal sign. So when that happens, the easiest or the best route to solving this would be to combine those like terms on the same side together. So 17 minus 11 will give you 6, and because they're both x terms, your answer will also have an x, so it'll be 6x. Once you're done combining the like terms on the same side, you're now continuing on as if it were just a regular two-step equation by doing your addition or subtraction to move the number without the variable to the other side, in this case an 8. And then 20 minus 8 would leave you with 12. And then, of course, you would divide by that 6 to solve, and you would get x equals 2. So here's a few more practice examples that we can do. So to solve this first equation here, we have two like terms, once again, on the same side of the equal sign, 9 minus 13, which is negative 4x. We have plus 7 equals 31. Subtracting 7 on either side will leave me with a 24. And then we divide by that negative 4 to continue getting the x alone. Negative 6 is our answer. If we take a look at the next problem, this time we have, again, two like terms on the same side of the equal sign. Negative 5 and positive 8 give me a positive 3x when I combine those. Now I want to move my 13 over using my inverse operation of subtraction. 3x equals negative 15. Dividing by 3, x equals negative 5 is our solution. Okay, the next equation also has two like terms. They're just not right next to each other, but it doesn't really change much of what we do. We just have to make sure the sign in front of the number that has the like term stays with it. So this negative stays with the 8. So 15 minus 8 would give me 7x, and then I have minus 9 equals 12. Now using my inverse operation of addition to get rid of the 9, 7x equals 21. Dividing, x equals 3. Number 4 here, again, we have two like terms on the same side of the equal sign. Negative 2 and negative 4 would combine to give me negative 6. Subtracting my 18 to the other side. Now I have negative 6x equals negative 42. When I divide that by the negative 6, since the negatives cancel out, I end up with a positive 7 for my answer. All right, and number 5, 9d minus 2d would leave me with 7d. And then I just continue to solve that problem. 7d equals 28. Divide by the 7, d equals 4. And then finally, this last one. The single x here really has a coefficient of 1, so those will combine to give us a 10x. And then we just finish solving using those inverse operations. 10x equals 20, divided by 10, x equals 2. All right, so the next type of problem we're going to go over is using the distributive property. So in this case, whenever we have a problem with parentheses in it, the number in front of the parentheses will get distributed to those parentheses. However, the sign that's in front of the number will stay with that as well. So this here is a positive 3 getting distributed to the 2x and the minus 1. So I still have my 4x. Then I'm going to have plus 6x minus 3 when I do my distribute. Now we continue just like we did on the last set of examples. So 4 and 6 are like terms on the same side of the equal sign, so we could simply combine those like terms. And then we finish solving the problem using our inverse operations, in this case addition. and then division to get the x by itself, and x equals 2. All right, so a couple more of these problems. So on this one here, we're going to be distributing the 3. It is a positive 3, so we don't have to worry about any sign changes. So we have 3x minus 12, because 3 times negative 4, plus 4x equals 16. Now in this case, the two like terms are separated, but they're still on the same side of equal sign, so we're going to combine them into 7x. And then I still have my minus 12 equals 16. Using my inverse operations, I'm going to add the 12 to the other side, give me 7x equals 28, and then I divide, x equals 4. Okay, number 8. Now this time's a little different. You'll see that there's a 6 in front of the parentheses that we're going to be distributing, but in front of that 6 is a subtraction sign. So we're actually going to be distributing a negative 6 here, and it's very easy to miss that negative for people. So negative 6 times positive 3 will give me negative 18x, and negative 6 times negative 3 is going to give me a positive 18 there. So be very careful when there's a negative on the number you're distributing. Now my two like terms on the same side will combine to give me a negative 9x, and then I'll just continue to solve this problem. So I have negative 9x equals negative 9, and of course when I divide, I end up with x equals positive 1. Okay, number 9. I'm just distributing a positive 7 this time, so that shouldn't give me too many issues with regarding signs. 7 times 3 is 21x. 7 times negative 1 is negative 7. Now the like terms here are going to combine to give me a positive 19x. And then I'm going to add 7. 19x will equal 38. Divide, and I'm left with x equals 2. On the next problem, we're distributing a 5, 10x plus 40 minus 6x equals 16. Finding those like terms to combine, so 10 minus 6 will give me a 4x, and I still have the plus 40 and the 16 on the other side. Subtracting the 40, 4x equals negative 24, dividing by the 4, and x equals negative 6. Okay, a couple more here. This one we're just distributing a positive 3. So we have 2w plus 3w plus 12 when we distribute. Combining those two w's as our like terms to get 5w plus 12 equals 27. Subtracting the 12. 5w equals 15. And then we would divide, and w equals 3. All right, next one. This time, once again, we have that negative value that's going to be distributed, so that's going to affect our signs here. So we have our 6x, and then we have minus 2x. But be careful, because we're distributing a negative 2 to the negative 5, which will give us a positive 10. Combining our like terms gives us a 4x. Subtracting the 10. And then dividing by 4, which is 9. Now, finally, we want to go over some problems where we have a fraction that needs to either be distributed or somehow we need to get rid of that fraction in the equation. So there's two methods to doing this. So one method is what we've been doing, using that distributive property. And then the other method would be that you could use the reciprocal to get rid of the fraction first in these types of problems. So if we want to do the distributive property, and I'll go ahead and do that one first because you're probably a little more familiar with that. So if we're doing the distributive property, we're going to distribute this 3/4 here. Now, when you distribute the 3/4, remember that when you multiply fractions, if the number that you're multiplying to is not a fraction, you can put it over 1. And if you're going to multiply 3/4 times 5x, the 3 is going to get multiplied to the 5x, giving you a 15x. And the 4 is going to get multiplied just to that 1, making it 15/4 x. Now, when you distribute to the next part there, you end up with a -12, because 3 times -4, and then 4 times 1 is 4. Now, of course, if you could simplify these as you're multiplying, that's totally fine. So a lot of people would cross cancel or just kind of do it in their head. 15/4 does not simplify at all. However, 12 divided by 4 does simplify to 3. So you might end up just getting that right away from the beginning, knowing that those 4s were going to cancel when you multiply. Once you get to here, we want to isolate the x, so we're going to add the 3 to the other side, giving us 15/4 x equals 15. And now we're just going to multiply by the reciprocal to get the x alone. In this case, our reciprocal would be 4/15. And it just so happens that these 15s would also cancel, and we would be left with x equals 4. So using the distributive property, that's how you would do that problem. Now, using the distributive property is fine. However, sometimes the numbers that you're going to distribute to are not going to simplify or cancel very easily. So in the last problem, or in this same problem, we did it by the distribution method. When you multiply the 3/4 times the 4's canceled, and you were left with just that -3, which wasn't that big of a deal to add over, and then you just had to do that one reciprocal at the end. So it wasn't really too bad. But if the 3/4 times 4 gave you a fraction that you couldn't simplify, it would have made it a lot trickier to finish solving. So another option for these kinds of problems is to just go ahead and get rid of your reciprocal, get rid of your fraction by multiplying by a reciprocal straight away. Now, if you do that, you have to multiply everything by that reciprocal, but everything that's being multiplied together. So for example, like the 3/4 and the 5x minus 4, that's really technically could be considered one term because it's multiplying. But if you had another like +8 or something after the parentheses, then you would have to also multiply that by the reciprocal too. So that's the con to this method. In a longer, more complicated problem, you might forget to multiply everything to it. In this case, so we only have basically one thing on each side that needs to get multiplied, so it's pretty straightforward. So now, of course, the whole purpose of doing that was to get rid of that fraction there on the left, leaving us with just 5x minus 4. And on this side, we have 48/3, which, of course, simplifies because 3 and 12 could have reduced, or 48 divided by 3 is 16, whichever way you do it. And then you just finish it up by adding the 4. So 5x equals 20. Divide by 5, x equals 4. Notice we got the same answer regardless of which method we chose. So I typically tend to like using the distributive method if the two numbers that are going to get distributed to will cancel out. And the way I would know that is that this denominator of my fraction is something that these numbers can be divided by evenly. They're multiples of that number. So 4 and 4 I know is going to reduce or cancel, but 5 and 4 is not. So I probably would have done reciprocal method here, but either one wasn't too bad. But if you take a look at like number 13, for example, I would probably do reciprocal method here because this is a 1x and this is an 11, and neither of those are divisible by a 2. So it's probably going to give me a bunch of nasty fractions. So I'm going to choose to do the reciprocal method for this problem because now I just have x minus 11, and on this side, all I have to do is 9 times 2, which is 18, and then I add 11 and I'm done. So it's pretty straightforward to do it that way. Now, if I go to number 14, this time, because 2 and 6 are both divisible by 2, using the distributive property isn't such a bad idea, because if I do negative 3 over 2 times 2y, I get negative 6y over 2, which simplifies to negative 3y. When I do negative 3 over 2 times 6, I get negative 18 over 2, which simplifies to minus 9. So you can see when you distribute here, because the 2 and the 6 are divisible by 2, the fraction kind of goes away as part of the process. Now I would just add 9. Negative 3y equals 24. Divide by negative 3. Y equals negative 8. Now, of course, I chose to do 13 with the reciprocal, 14 with the distribution method, but you could have used either of those methods for either problem. You should have still got the same answer regardless. It might have just been a different, way to get there. Okay, so 15, again, this is one of the problems where I look and see, okay, 4 and 1, they're not easily divisible by 7, so I'm going to use the reciprocal here, meaning I'm going to multiply both sides of my equation by 7 over 5. So on the right-hand side, I just have that 4z minus 1, and on the left, I could multiply 7 times 15, but that's kind of big to do in my head, so I'm going to instead reduce here. And now I can do 7 times negative 3 pretty easily in my head. Adding the 1, negative 20 equals 4z. Divide by 4, and we know z equals negative 5. And then this one, 5 and 12. Okay, so 12 is divisible by 4. 5 is not, but so I'll have to do a reciprocal at some point anyway for that, but since the 12 is divisible by 4, I could do distributive property, wouldn't be that bad. So it's up to you. This is a negative fraction, so just make sure when you multiply by the reciprocal at any point, you're multiplying by the negative as well, because you want those negatives to cancel. So on this side, I have 5m plus 12. And on this side, I have negative 4/3 times 36 over 1. However, 3 and 36 I can reduce before I multiply, giving me a negative 48. You could certainly multiply it out and then simplify as well. You should get the same thing. Then we're subtracting 12. I get negative 60. Divide by 5. And m equals negative 12. Okay, I'm going to do a few extra practice problems of these fraction type just so we can kind of get the hang of it. I'm going to do a couple with the distributing, because if you'll notice on these, 8 and 16 are divisible by 4, so distributive property should work out pretty nicely for this one. So if I do 1/4 of 8, now remember this is really like an 8 over 1, so if you're not sure in your head what's 1/4 of 8, which I know it's 2, but let's say you had to multiply it out the long way. So you do 1 times 8x, 4 times 1, and then now you know 8 over 4 reduces to 2x. When you multiply the 1/4 to the 16, you might know that 1/4 of 16 is 4, and that would be great. If you don't, 1 times 16 is 16. 4 times 1 is 4, and then you could divide or simplify from there. So many of you won't need to write out that stuff there. You just do that in your head. Now we're just subtracting the 4, giving us 2x equals 60. Dividing by 2x equals 30. Okay, next one. Again, I'm going to try this one by distributive property because 4 and 10 are both even numbers and they're divisible by 2. So half of 4, which is 4 over 2x, half of 10, which is 10 over 2. And of course, you probably know that this is going to be 2x minus 5. Adding the 5, 2x equals 28. Divided by 2, x equals 14. Okay, and again, we have 2 more here that we could use distributive property for, because 5 and 30 are divisible by 5, 12 and 3 are divisible by 3. So if I work out this one here, 1/5 of 5, the 5s could cancel. That's just going to give me an x. And 1/5 of 30 is 6, so it's just a -6. If you need to write out that previous step, then you can. Adding 6 to the other side, x equals 40. Okay, D, same idea here. We have the 12 and the 3, both divisible by 3. 1/3 of 12, or 12 divided by 3 is 4x. 1/3 of 3, or 3 divided by 3 is 1. And then we add the 1. 4x equals 20. Divide by 4, x equals 5. Okay. All right, again, the next two problems, they also have numbers that you can divide by evenly if you distribute. So 4 and 8 are divisible by 4. And then over here, we see 15 and 10 divisible by 5. The difference on these now is the numerator is a number other than 1. So let's just see how that affects our problem. So when I distribute 3/4 to 4, I remember that's really a 4 over 1. The 4s would cancel. I'm left with 3x. When I distribute my 3/4 to 8, which is really 8 over 1, I could reduce my 4 and my 8, and 3 times 2 is 6. Or you could just write 24 over 4 and divide it out. And then, of course, subtracting 6, dividing by 3, x equals 2. All right, next one, 3/5 of 15. Now again, 5 and 15, I could cross cancel or reduce there and make it a 1/3, and that would give me a 9x. Or I would have 45 over 5, which would simplify to 9. When I distribute the 3/5 to 10, the 5 and the 10 could reduce to a 1 and a 2, and then 3 times 2 is 6. Or you'd have 30 over 5, which divides to get 6. Subtracting 6. 27 equals 9x, dividing by 9, x equals 3. All right, now the last couple, trying to think here. Okay, so these two, again, you have options of how you'd like to do them. Do you want to do them by reciprocal or distributing? And again, the 6 and the 9 divisible by 3, 9 and 15 divisible by 3, but we've just gone over a bunch with the distributive method, so I'm going to do these the other way now, just to get a little practice. So I'm going to multiply each side by 3/4 so that I can get rid of that fraction there, and I'm going to multiply it over here as well. So now the 6x minus 9 is all alone, and over here, I could do 3 times the negative 24 and then divide it by the 4. But I like to just cross cancel to just make it a little easier to do in my head. So 3 times 6 there is going to be that negative 18. And I'm going to add the 9. Negative 9 equals 6. And this answer, we're going to end up with a fraction. So you have to make sure it's in lowest terms. You could have negative 3 over 2. Or you could have written it as negative 1.5. Preferably not a decimal, since there were no decimals in the original problem. Even though negative 1.5 would technically be accurate, we would want the answer represented in the same type of format the original problem was in. Okay, this one, multiplying by 3 over 2 to cancel out. Same thing on the other side. I now have 9x minus 15 equals. And if I want to reduce the 1 and the 2 and the 20, I have a 1 and a 10. So that gives me a 30. Adding the 15 over, 9x equals 45. Dividing by 9, x equals 5. Now if you did do those by distributive method, you'd get the same exact answer. Okay, and then the last two, these ones, even though the number, the constant, the 6 is divisible by 3, this is a 1x, and 1 is not divisible by 3. Over here, 10 is divisible by 2, but the 1 is not. So you really have a choice. It doesn't matter. Again, you can use whatever method. I'm going to do reciprocal because I just rather get rid of the fraction from the beginning. So now I have x plus 6 equals 3. Subtract 6. X equals negative 3. On this one, I'll distribute this time just to mix it up. We have 1/2 x minus half of 10, which is 5. We're going to add the 5. That gives me 1/2 x equals 12. And now I still have to multiply by reciprocal anyway. X equals 24. All right, so those are some multi-step equations. There's still a couple more down here. Let's see. I think these are the last two, actually. Okay, so again, I'll show you how these would work out. We'll do the first one. Now, 6 does not divide by 4 evenly. 10 does not divide by 3 evenly. So while you're more than welcome to distribute these, it will definitely be more work to use that method. So I would recommend you use the reciprocal method for these. That would leave you with x plus 6 equals, now the 12 and the 3 can reduce, and then 4 times 4 is 16. X will equal 10. It's just so much simpler to do it that way. Here I'm going to multiply by 3 over 2, leaving me with x minus 10 equals, the 8 and the 2 can reduce. 4 times 3 is 12. Adding the 10, x equals 22.